Hello, welcome to Advanced Design and Innovation. I'm Mr. Rotstein, and this is the capstone course for the 3 credit design and drawing sequence. This class is far and away my favorite class to teach. I'm really excited to have your students here with me. Just to get this stuff out of the way, grading is very much on the students as far as I grade based on what they provide for me. 60% of the grades are based on projects, 30% is on kind of minor classwork, and 10% is participation. It's all hands-on in this class. Extra help. This year it's Tuesdays and Wednesdays. So Tuesdays are period 3 and after school, and Wednesdays are after school as well. And this year, students need to email me in advance in order to join our extra help sessions. Now, onto the course itself. There are basically 2 main goals that I have for everybody this year. One is to give them an opportunity to take and pass the CSWA exam. That's their opportunity to become a certified SolidWorks associate. So SolidWorks it's kind of the last skill that they've yet to learn with me. So they've already become really proficient in mechanical drawing by hand, in CAD drawings, which is CAD is computer aided design, and they've done some CAD software with me, primarily AutoCAD, which is what we use for 2D drafting, and SketchUp, which is what we've used for 3D designs in the past. This is a much more advanced parametric modeling piece of software. So they're learning it now. It's pretty complex to start, but I can already tell that they're getting the hang of it. And my goal is for them to become really proficient in this software by the end of the year. Now, if they become proficient enough and they pass this certification exam, it gives them a certification that they carry with them. So this is something that they can put on resumes, that they can put on college applications. And the thing is, it's a very difficult exam. The passing rate has not been very high historically. I'm hoping to continue to bring that up. But knowing that it is so difficult, I want you folks to know this has no bearing whatsoever on their grade. I just want them to have an opportunity to take this test. It's a 3-hour practical exam. I offer it from my classroom because we're remote this year. I'm sure there's going to be an opportunity to do it remotely or from the classroom, depending. But I just want to give them a chance to take it. They get to take it for free because we have the licensing for each seat for the test. So that's one of my main overarching goals. The other goal is for them to have a portfolio of their work that they are proud of. So a high quality portfolio, one that they'd feel comfortable, giving to a college for acceptance or to a potential employer. And it's going to be a culmination of the work they've done over the 3 years that they've taken coursework with me. And that's really it. And that's how flexible this course is once we've learned SolidWorks and become proficient in it, we're just going to be completing a myriad of different design challenges that allow us to create a portfolio and allow us to challenge ourselves, us being the students, in our ability to problem solve and to convey our solutions to a problem through different mediums. So we're going to be doing some architectural kind of designs. We're going to be doing some engineering type work. It's really open-ended, and year over year, we find ourselves doing some projects over again, and a lot of projects I just do one year and we don't do them the next year. So it's really open, and I'm welcome to suggestions from students. If they have some project ideas that they want to complete, I can usually work that into the class. So, like I said, the main skill that's new for them is learning this piece of software, learning SolidWorks. So we're working through that now. We're going through some tutorials. We're having some nice discussions, and if you ask your son or daughter, I hope they'll tell you that at first it was pretty confusing. It still might be a little bit. We're still early in the year, but I hope it's becoming easier and more manageable for them. It seems like it from the work I've seen. So some of the projects that we've done in the past and some that we might do in the future. This one is a future project. This is one I have not done that I'm excited about. CO2 dragsters, so these are CO2 powered cars. They are a classic technology education project. We're trying to do it with a spin this year. So I'm going to have students design these cars in SolidWorks first, so design it digitally. And then what we'll do is we're going to print a side view and a top view of their SolidWorks model, and we're going to glue it to the wood block that you see on the left. And then we can use that as a template. And we have equipment here in the room. We have a bandsaw and a couple of scroll saws, and we'll be able to physically cut out the car, sand it down, paint it, and we'll be able to race them. Now, because we are working with this hybrid model, I have to figure out the most practical way to do it. It might be that I do the initial cuts for students and then they sand and finish. I'm going to work through that, but I'm excited to have this as a new hands-on addition, something for them to take home. Another great project we've done in the past that we will definitely do again this year is the reverse engineering project. So here, I provide students with just random dollar store items. In this case, for this particular year, that item was, they called it a math kit, but it's really like a little drafting kit. And what students do is they take apart whatever that product is, analyze and evaluate and measure every single component, and then what they do is they model that component in SolidWorks. So they recreate the entire product for, that's like kind of the first half of the project. And the second half of the project is they take that product and they reimagine it and take the parts of it and they design something completely different, with the main goal of being increasing the value of the product. So here this math kit was, I believe it was $1.49. So they had to come up with a new product using the same materials that is more valuable than that $1.49. And these particular students came up with a board game that they had invented. So I can kind of show you the breakdown. So here's their fully assembled, rendered math kit. And again, they did this all themselves. This is there's no scanning of any parts. It's them just taking measurements and recreating this from the ground up. So they've documented and recreated the ruler, the triangles, the erasers along with the case, the sharpener, and of course the blade is a separate part. So we have to take it down to its absolute bare minimum in terms of number of parts, even the tag. So a lot of attention to detail. And this was 2 students. So here's some brainstorming. These are their ideation sketches in terms of thinking of, now that I really understand these parts, what they're made from, the properties of the materials, what could we reimagine this into? Oh, sorry, kind of flew through that. And again, they came up with this board game. And this is a board game for which they had their own set of rules, and they explained it to us, and it looked like it was a lot of fun. But again, by the end of this project, that's when they really feel confident and comfortable, and they can say with confidence that they're actually really good with this software. And that's my goal for the students here, is to get really good at the software and to have a high-quality professional portfolio. So by the end of this, I think we could say that they do have both of those things.